So the last section with level 11 is 11.4, which is inverses of matrices. So we've talked about adding, we've talked about subtracting, we've talked about multiplying by a scalar, we've talked about multiplying two matrices, but we have never talked about dividing two matrices. So with matrix operations, the idea of division doesn't exist, but we can kind of trick these computers to thinking that there is division by saying we're multiplying by something's reciprocal. So if you remember, we have something times its reciprocal, that's equal to 1. Well, normally we say, oh, that's just dividing. But we don't have division, so we have to improvise in a way that we say this is the reciprocal. So as you see what I wrote here, it says when you multiply by a number by its reciprocal, you get 1. When you multiply by a matrix by its inverse, you get its identity matrix, which is like 1 for matrices. So if you have A times its inverse, you get I. That bold I means the matrix. So with identity matrices, they are always square matrices that have 1 going down the diagonal and 0 everywhere else. If you multiply something by its identity matrix, you get 1 back out, which is the definition of an identity. It's much like saying something times 1 gives you the same thing. So we write them as 2 by 2, or 3 by 3, or 4 by 4. So we get to this definition. The inverse of A is A inverse only when A times its inverse equals the identity matrix. So sometimes there are matrices that have no inverse functions for them. So just as a proof of our first operations, just to make sure that we know what we're doing, if we multiply A times I of 3, remember this is a 2 row by 3 column, so we want negative 1, 2, 0, 0, 1, 3 times 1, 0, 0, 0, 1, 0, 0, 0, 1. That's what we're multiplying. So if we go across, our answer should be, this is 2 by 3 and a 3 by 3, so we should get a 2 by 3 as an answer. And we go negative 1 plus 0 plus 0. Then we have, negative 1 plus 0 plus 0. Then the next one should be 0 plus 2 plus 0. And then the next one should be 0 plus 0 plus 0. And then we go second row, first column, 0, 0, 0. Then 0, 1, 0. Then 0, 0, 3. Which is exactly what we wanted to begin with, which is our original. Same thing with B. If we have this is a 3 by 2 times a 2 by 2, our answer should be a 3 by 2. So we are multiplying 3, 2, 4, 6, 5, 2 times its identity, which is called I2, which is 1, 0, 0, 1. So again, row, column. 3 times 1, 3 plus 0. Then if we went the next row, 0 plus 2. 4 plus 0, 0 plus 6. 5 plus 0, 0 plus 2. So this is if we're getting the hang of our multiplication here, just multiplying something by its identity gives you itself. So then how do we find the inverse of a function? We're going to go 2 by 2s, and then I'll show you 3 by 3s and how to prove it in 2 different ways. So example 2, show that the inverse A is this. So in order to show something inverse, we can multiply them, and if we multiply them, when we get the identity. So we should have A times A inverse equals the identity. So we could do 3, 1, 2, 1 times 1, negative 1, negative 2, 3 equals. So if we do 3 plus negative 2, we get 1. If we do negative 3 plus 3, we get 0. If we do 2 minus a negative 2, 0. And if we do negative 2 plus 3, we get 1. So these two are our identities. Now I want you to, if you look at this carefully without me telling you, how are these two related? Well, we have a 3 and a 1 here, and then we have a 1 and a 3 on the diagonal. So we switched the A and the B, and then we made the C and B negative. So if you see down here, which I know I gave it away because I was trying to save space, the inverse of a function for a 2 by 2 matrix is 1 over the determinant, or 1 over D, times switch the A and the D, the diagonal, and make B and C negative. Those stay. These switch, these become negative. So easily, if we did, what's A inverse? Well, switch these two. So we have 1 and 3. Make those two negative, negative 2, negative 1. And we're going to multiply that by 1 over 3 minus 2, which is 1 over 1. So really, that's all we had to do. For a 3 by 3, also, sorry, I don't have any more practice problems on this. Please do some of these by hand. So for a 3 by 3, I wanted to show you something called reduced row echelon form. There's not as simple a way of doing this. There is, it's 1 over the determinant times multiple different determinants, and I don't want us to get into that kind of minutia. So to find the inverse, A inverse, what we're going to do is we're going to type this into our calculator. Reduced row echelon, RREF stands for reduced row echelon form. If you want to know what that actually means, ask me in class. And then you're going to type in this matrix into your calculator. So we're going to go 1, 1, 0, negative 1, 3, 4, 0, 4, 3. And then, I know this dash doesn't really exist on your calculator. We're going to write out the identity matrix next to it. If we do that, and just to save some time, I've already entered this into our calculator. And let's zoom in here. So you see, I wrote our matrix. This is our 3 by 3 here. And then we have our identity matrix right here. Reduced row echelon form is if you go menu, and then you go down to 7, which is matrix. Reduced row echelon form is number 5. So if we do that, we hit enter, you will see that the left side became our identity matrix, and our right side is our inverse function. So our inverse is 7 fourths, 3 fourths, negative 1, negative 3 fourths, negative 3 fourths, 1, 1, 1, negative 1. This is our inverse. If I typed in our matrix that we started with, and it was a 3 by 3, and we go 1, 1, 0, negative 1, 3, 4, and 0, 4, 3, and I put that to the negative first power, I get the exact same thing. So we have multiple different ways because reduced row echelon form was originally how people did those by hand, but A inverse is equal to 7 fourths, 3 fourths, negative 1, negative 3 fourths, negative 3 fourths, 1, 1, 1, negative 1. So people used to do these by hand to solve much larger systems. And then this gets back to our point of why this is useful. Well, remember when we first started, we said A times B equals C. Then we wrote our augmented matrices. So we wrote 1, 1, 0, negative 1, 3, 4, 4, 0, 0, 4, 3. We wrote our X, Y, Z, and then we wrote equals our C, which is 3, negative 3, 2. And then we did B equals A inverse times C. and that gave us our solution. So with all of this, I hope you have come to learn a little bit more about matrices than you knew before, and good luck studying for your second to last test.